Hello, so today we'll be talking about the remainder theorem, factor theorem, as well as the process of long division for polynomials. So first of all, to start with the remainder theorem, this is just for a shortcut for finding the remainder. Now you can do this using long division, but if you're given that you're dividing an expression p of x by a binomial b of x plus a, you can simply sub in the negative of the constant that you're divided by the coefficient of the x, which is b. So your remainder will just be p of negative a on b. Now for the factor theorem, now first of all, let's think about dividing binomial. If you divide by a binomial and you get a remainder of 0, this means that whatever you divided by has to be a factor, right? So this means that if your remainder is 0, so if p of negative a on b is 0, then this must mean that what you divided by, bx plus a, has to be a factor of the function p. Now, let's go through an example here to demonstrate this. So find the remainder when this cubic expression here is divided by x plus 3. Now, first of all, we need to think about what the values of b and a are from our general rule here. So x plus 3 over here, our coefficient of x is 1. And our constant here is positive 3. So to find the remainder when this cubic over here is divided by this binomial, then all we need to do is p of negative a, which is 3, divided by 1. So essentially we have p of negative 3. Sub that in, we get negative 27 plus 4 times x squared, so x here is negative 3, so we have 36 minus 7. This gives us a remainder of 2 when you divide this one by x plus 3 over here. Okay, so here we're given that when we sub in negative 2 into our function p, we can factorize p of x, which is our cubic over here. Okay, so what does this mean over here? Now we refer back to the factor theorem. If p of negative 2 is equal to 0, this means that you can have an a value of negative 2. Oh, sorry, the a value has to be positive 2 because remember what's inside the bracket is negative a on b, got negative 2 here, and b can be 1. So this must mean that x plus 2 is a factor. So if x plus 2 is a factor, this means we can do some long division here to find out what our other factor is at the top. So we have x plus 2, that's what we're dividing by. And we're going to have our cubic expression, 2x cubed plus 3x squared. We don't have any x's, but we still need to account for them. So 0x here plus 4. So hang on a moment, why are we using 0x here? Well, think about it this way. If you have the number... Yeah. So if we have the number 2017, and this means that we have 2000s, 0 hundreds, 110, and 7 ones. Now, if we didn't account for the 0 over here, then we would have the number 217. Obviously, these two aren't equivalent to each other, so we do need the 0 over here as a placeholder for the number of hundreds. Similar concept here for polynomials. We need 0 here as a placeholder for the number of x's we have. So when you do your long division, you need to see how many times this leading coefficient goes into the biggest one over here. So you need this 1 over here to be multiplied by 2 to get 2x cubed here. And since we multiply this whole binomial here by 2, this means that the 2 over here will become 2 times 2, so we get 4x squared. And since we went into this expression 2 times, we say it's actually gone into it 2x squared times. Because naturally, if you divide a cubic expression by a linear one, you're going to end up with order of 2. So afterwards, you need to find the remainder of between these two coefficients. So 3 minus 4, you get negative 1, or negative x squared. I want to drag this 0 down over here. So how do we get from 1 to negative 1? Well, we need to multiply by a number. So we can multiply by negative 1 here. If you multiply this whole thing by negative 1, you're going to get negative 2 instead of positive 2. So minus 2x. And since the coefficient here is negative 1, our next coefficient is going to be negative 1. So it's minus x there. 0 minus 2, or minus negative 2, positive 2x. Drag the 4 down. And so, same procedure again. We have the coefficient of 1 here, we have the coefficient of 2 here. This means we need to multiply by 2. And since we multiply by 2, our next coefficient, or last coefficient, our constant has to be 2. And we've just got to check that these two numbers match up. Because if you subtract these two, we are going to end up with 0 here. Our remainder is 0. And we need to check that our remainder is 0. Otherwise, there's two possibilities. Either x plus 2 isn't a factor of our expression here. So remember, if it's not a factor, this remainder shouldn't be 0. Or if you are really confident that this is a factor, then that means that we need to correct some sort of process here, which we may have done this calculation on. So now we know that this quadratic is a factor, as well as x plus 2. So the function p is going to be x plus 2 times 2x squared minus x plus 2. Okay, so let's see what we can do here. So this is a cubic expression, but can we factorize this further? Maybe. So it's a quadratic term over here, but if you want two linear factors out of a quadratic, we've got to make sure the discriminant is actually greater than 0. So let's check out what the discriminant here is first. So recall that the discriminant is b squared minus 4ac. B over here is negative 1, all squared. 4 times a, which is 2, and c, which is also 2. So we get 1 minus 8, which gives us negative 7. So since that discriminant is less than 0, then this expression over here is our simplest factorized form of p of x.